Welcome, everybody. Glad to have you joining us this afternoon. I'm Joy Hall Bryant with DIR. I am super excited about this one because I've been trying to get this presenter for us for a few months, if not longer. Today, we're going to be talking about It's All Analytics, Separating the Hype from Reality. So again, I'm Joy Hall Bryant. I'm Program Director for IRM Outreach and your host. My co-host, Ed Kelly, will introduce himself in a moment, and then Scott Burke, our presenter, will take over. Lots about Scott and his, but let me say, I have his book. I've already started reading it. So I'm going to be quiet. Let me go ahead and turn this over to Ed for a few remarks, and you guys have a great session.
Great. Thank you, Joy. Appreciate that. Good afternoon, everyone. Thank you for signing up. And to Joy's point, I think this is going to be a great session. Scott and I have talked a bit about kind of his role and his experience, and I'm going to let him kind of dig into his background a little bit. As Joy said, my name is Ed Kelly. I'm the Chief Data Officer here at DIR for the state of Texas. And, you know, when you think about this particular topic, it's all analytics, separating hype from reality. You know, it really applies to what we're all dealing with today, the current situation and this pandemic, and dealing with, you know, the impact to public health, the economy, and our society overall. And I think what leadership has certainly recognized is the value of data, and more importantly, leveraging this data by applying analytics so that it can become so critically important to helping and making decisions. So our guest speaker is Scott Burke, and as I said, I'm gonna let him get into his background a bit, but briefly, you know, he has 25 years of experience solving healthcare problems through science, statistics, machine learning, and business knowledge. He's got degrees in biology and chemistry, master's degrees in business finance and data mining, also a PhD. Scott has a wide background of education and experience. And he's also had some very interesting roles throughout his career. So I'm going to turn it over to him. Welcome, Scott, and it's all yours.
Thank you, Ed. I really appreciate that introduction. And Joy, thank you for having me and putting this on. I really appreciate the opportunity to share this today. I'm going to go in and start with where this all began, which essentially I saw a real need for education, and I love learning. And so my goal today is that we all learn something in this hour, right? I have been doing this a long time, and you know, I ended up writing a book about this, which hopefully is displayed. And it's part of a three-part series on analytics. And so the reason I wrote this is because I really felt something was missing. There are lots of great books on there on how to use tools and techniques, you know, specific to things like AI and machine learning and, you know, creating visual dashboards, BI, working with data. And as Ed said, this is just critical these days, the whole data-driven movement and technologies that support that. And, you know, there were also a lot of great books about Python and R and other languages. But what I really saw missing was a high-level view of the landscape, how all these pieces really fit together. And in the end, I came to the conclusion it's all analytics. And I'm going to share with you today why I view it that way. And so if you've ever had a foundations class or a 101 class where you take a high-level view of a broad landscape, that's my goal here today and with this book. So we'll cover as much as we can in an hour. And just to let you know, coming in 2020 will be the second book. And the second book is a different take. So if I had to sum it up, the first book is Foundations, and it's literacy, kind of a 101. And the second book is all about designing the organization and your IT assets for success in analytics. All right, so let's just kick it off. Let me share what I really want to do here is leave you with three themes or takeaways The first one is democratizing analytics, which is a common term now, which basically means power to the people, right? And we'll get into this, but at any level, whether you're a consumer of analytics, a creator of analytics, or just a citizen today, you are impacted by analytics. And also this notion of a team sport, the fact that we can all play a part, whether we are dedicated data scientists or statisticians doing some real nuts and bolts type things, or whether we're supporting an activity or a line of business or some part of the organization, and we are a consumer, a user of analytics, we need this knowledge. This is a movement. And with that, the need for data literacy, right, which is the ability to speak the language of data and analytics. Everybody needs a basic proficiency in that as far as I'm concerned. And then the story of better together. The fact that teams work together when everybody has a role to play, and also methodologies work better together when you use them in an orchestrated way. So again, analytics impacts you. One of the things that I'd like to do is, I'll try this out, is if you've, as Joy said earlier, you should have the ability to raise your hand. If you produce any sort of analytics, reports, dashboards, if you are doing machine learning, could you raise your hand?
So let's see what kind of responses we get. Hands are going up. Let's give it a moment. We have 116 people online right now, and it looks like 30% are saying yes to that.
Great. Okay, great. Let me do another quick raise of your hand if you are a business consumer. In other words, if someone is providing you a dashboard, you have some sort of analytics that you're using as an activity in your business to make better decisions, could you raise your hand? And these are not binary, these are not exclusive, right? So you could be both.
Less hands, which is a little surprising. They may not be interpreting that as broadly as I did. We got 24%.
Okay, great. All right, so quite a few. And even if you don't fall in the category 1 or category 2, you certainly are impacted by providers of products and services, right? Because every major brand is using artificial intelligence and machine learning to learn about you, how to market to you, how to improve their revenue or their place based upon your actions. And then certainly even as citizens, right, and media consumers, we know that we have targeted ads and viewer preferences by demographics, and that data is being used in that way as well. So I put out a couple of things here on, real issues that impact all of us, right? When you have so many sources of data, and then you have on top of it all of the advanced computing power that we have these days, sometimes it can be kind of a dangerous combination. You may have heard of Cambridge Analytica and some of the things that happened there. That was a little while back, but let me just throw out a few more. And you can see on the screen that, Twitter just this month warned that it's likely to be fined hundreds of millions of dollars for misusing personal data. And then Uber, this was very interesting to me, was that Uber was tracking data after riders completed their rides. And that's a stated fact. They admitted to such, that even after you turn the app off, Uber was tracking your geolocation. Now, when you think about that, when you think about all the data that is provided, where you are, and you cross-correlate that with all the mapping data, the fact that they know with Google pretty much where every business is, or actually many residences are, right? You think about the maluse of that type of data with very sophisticated artificial intelligence. It's not a pretty picture. And then there are some that are saying that that with an iPhone you could actually track that even after you deleted the app itself. Uber, I don't think, is admitted to that, but there's some people that said that Uber was even using that after the fact. So, and then this last quote, I like this from John Zittrain. So he said, I think of machine learning, artificial intelligence, kind of like asbestos. It turns out that it's all over the place, even though at no point did you explicitly install it, and it has possibly some latent bad effects that you may regret later after it's already too hard to get it all out. So, something to think about. What's driving a lot of this? It's data and how many varied sources and the explosion of data that it's happening, right? But is data the new oil? Some people have said that, so I'm not really sure about that. We know what to do with oil. We know how we've been at it a long time. We know what to do with it, but we don't often know what to do with all this data. And so the takeaway from this slide is that if you just collect data and that's all you do, then you're wasting a lot of money, because it takes money to source the data. It takes money to store and keep the data. It's a big security risk. I'm sure you've heard of a security breach within the last year, and every time this happens, the cost goes up. And in fact, 2019, the Pullman Institute said that the average breach was costing almost $4 million per breach, which was a 1.5 points above the previous year, and that the global cost in 2020 is estimated to be $2.1 trillion just for data breaches. So if you have all this data and it's just lying around, it's never used, then it's simply just a cost. And then you can see that second bullet, the statistic there, that as much as 90% of data, big data, is never analyzed. And so how do you turn the corner? Well, we're going to talk about data literacy today, basically talking about squeezing the value from that data. And certainly one of the best ways to do that is to create and deploy analytics. And this is from the book. It's not technology that is hampering the progress. It's a lack of vision, human capital, and execution. So this graphic shows the growth of global data over the last few years. And you can see here, this is not linear. This is exponential growth. And it's pretty phenomenal what's coming out, estimated to be 175 zettabytes by the year 2025, and this is from IDC. And then some of the other interesting statistics is, if you've heard of IoT is the Internet of Things, or IoE is the Internet of Everything. And so one of the reasons for this explosion is all these interconnected devices. And I just can't believe the second bullet to me is just amazing. When you think that there's 7 billion people roughly on the face of the earth, and we have 30 billion connected devices. And of course, these devices can include, smart home and smart car devices. It could be, smart cities with, you drive around a major city, all the cameras are connected to the internet. You have traffic lights that are connected to the internet. And healthcare, you have all the medical devices from patient monitoring to implanted devices. Actually, now, if you get a pacemaker and defibrillator, those are connected through gateways into data centers today. One of the interesting examples that I've seen recently is the human as a machine, which for athletes, they're putting sensors all over the body and training professional athletes to their limits. So they know exactly, like, for example, mixed martial arts, MMA, they have all these sensors, and they know when people start to tire. They know how far within a bout that they are starting to get fatigued, and then they can train for unique performance based upon those cycles in that image, that fingerprint for that particular athlete. And of course, there's all kinds of other applications like agricultural 3.0, self-driving tractors, field sensors. So everything's being connected, and that's driving all of this data. But again, the lower points, less than half of structured data. Structured means like, is it in a traditional type of database, right, with rows and columns, and then less than 1% of the unstructured, the free text, the video, the audio is actually being used for any purpose. So this is a bit of a rant slide. We don't have data democracy. Let me do another quick raise of the hand. How many people have heard we need to be more data driven?
Seeing some hands going up, still changing. That got a reaction. So at this point, 55% of our audience and climbing agrees they've heard that.
All right. Well, some people might be getting something to drink, because I can't tell you the number of times that I've heard we need to be data driven. In fact, I've heard it for over 30 years, and we're still saying it. What happened? One of the things that's happened is there's a lot of hype in the cycle, right? So there's the marketing hype, and there's the self-promotion hype, the media hype, the political hype, and so really people are frustrated because no one really knows where to find objective input, objective data, objective comment, the objective story. I can remember when I was at Baylor, I had a professor say, anytime that you read something, you should say, why is this person lying to me? And I thought at the time, well, that's crazy. That's so cynical. But I now see where he was coming from. And I'm not saying that any of these things is good or bad. Please don't get me wrong. It's as part of data literacy, we should know that there is bias coming at us all the time, right? And so if you understand the bias, then you can make a more informed decision as a data consumer. And so I have two biases right here in this presentation, right? First off, I really believe in analytics education, and I'm promoting it. That's part of my mission, and I kind of see it as a service, is promoting that education. And second, I'm promoting a book, right? So again, there's nothing. Hopefully, you don't find any fault in that. But you should be aware that I do have those biases, and pretty much everywhere as a consumer of data, and be it in business or personal, that everyone has a bias. And then, I'll just, with a little bit of rant, I'll say as a statistician, the whole COVID thing to me has been very frustrating, because, and it's mainly because when I first got involved, there was not any really good data. There were no standards. The things that I wanted to know as a statistician were not being reported at all. There were not good breakdowns. There were not good metrics. There was no way to standardize the data. And everything was kind of being treated across 330 million people. So I kind of gave up early on. So getting into data literacy, we need data literacy. I love these two quotes. Casey Panana, she said that imagine an organization where the marketing department speaks French, the product designers speak German, the analytics team speaks Spanish, and no one speaks a second language. That's essentially how a data-driven business functions when there is no data literacy. And then a follow-up quote, prevalence of data and analytics capabilities, including artificial intelligence, requires creators and consumers to speak data as a common language data analytics leaders must champion workforce data literacy as an enabler of digital business and treat information as a second language, by Valerie Logan. I like both of these, and I believe in them, and so that's kind of my mission right here, is to help with some of that data literacy. And Gardner came up with this 2020 estimate that half the organizations will lack basic data literacy skills. Why is it so hard? This is I won't go through this quote. This is actually part of a foreword from John Cromwell, and I really like what's in blue, the fact that many who need to know don't even know what they don't know. So, and that's a big part, right? So again, when I was talking about the fact that what motivated me was there are lots of great books on how to apply very specific things in code or different techniques. There's not a real overarching landscape and a view of kind of back to a 101 type out there. And we sit in these siloed fields, right? So I've been lucky enough to work in a lot of different companies and with a lot of different roles. And so this is, first off, it's afforded me a great career that never goes stale. And the second part is I have seen people from different backgrounds approach similar problems in much different ways. And one quick little anecdote there is I worked for a pricing optimization company in Austin called Zillion. And we had a group of pricing scientists, and we had people that were econometricians, we had computer scientists, we had statisticians, we had operations researchers, we had industrial engineers, physicists, mathematicians, etc. And so everybody kind of had a different background, but we were working on some common problems. And so it allowed me to see the way people with varied backgrounds would attack the problems, and it was quite rewarding. This is another thing that makes things very difficult, and this is the reason that the book it's all analytics. The black boxes are essentially statistical, machine learning, AI, artificial intelligence, optimization type buzzwords, even BI. So you have business intelligence and dashboards. From the statistics side, you have things like ARIMA and time series, controlled experiments, A/B testing, so all of these different things. And then the blue bubbles, you have basically where an analytics term is applied. So if you do a Google search on the word analytics, it's not difficult at all to find 100 different terms that is some definition of analytics out there. Some of them are relegated to a certain type of data, like text analytics there. I mean, obviously, you're analyzing text there, or in network analytics, you're looking at, a computer or a connected network. And then some of them are broader, right? So some of them apply to, customers, like customer analytics or sports analytics for sports, et cetera. But that is the one reason that analytics tended to be kind of the uniting term of a lot of these different things, and we include 50 different types of analytics that you'll see out there. And I apologize, this is an ugly slide, but it's really meant to be. It's meant to demonstrate the fact that it's a very complicated space. There's a lot of these different terms out there, but there's actually a lot of things that unify these terms together. And we're going to look at 4 classification of analytics now. So this is an important slide, and I want to spend some time on this. There's a lot of information here with a couple of key takeaways that I want to make sure that I leave you with. So at a very basic level, from the bottom left, you start with things that are lower in value and lower in machine computation or less algorithm, right? And then as you move up to the right, you have higher value and there's more machine computation and algorithm use as you move into the upper right, okay? And there are 4 types of analytics here. The bottom left, what happened, those are descriptive analytics. And so examples there might be, say, a dashboard, maybe a key performance indicator, some statistics like averages and things like that. So those are all, they describe something that happened, right? So they're what we call retrospective, meaning they've already happened, and we just kind of want to know what. All right. For example, like the COVID dashboard, right? So if you see a COVID dashboard, that's a descriptive statistics. That's something that's already been reported and happened. As we move up, we get into diagnostic analytics, and that answers the question, why did it happen? So let's suppose that, I apologize, I'll use a manufacturing example. So if we have like a batch of semiconductors that failed our tests, why did that happen? That is a diagnostic type of analytics. And then we move it into the next one, which is probably where most of the analytics are happening today, the predictive analytics, and that's the crystal ball. So that is, I want to foretell a future event, and I essentially want to know what the likelihood of something that's going to happen, or how much of it's going to happen. All right, so let's suppose that I want to predict the loan default, right? So I take in certain measures on an application, and I use those measures, and I come up with a score of the likelihood that someone is going to default on a loan. That's predictive analytics. Then as I move up to prescriptive analytics, that is, again, let's say that we have the loan example. What if I could take a next best action? I want to take an action for a loan recovery. Then that would be prescriptive analytics. It says, basically what can we do to make it happen, or what can we do to make more or less of it happen? Then that's kind of just pulling the levers that we have available to us to force an outcome in the future, right? And then the next one, which is not labeled as analytics, it's actually an optimization, is out of all possible actions, what is the best? So when I went back to, say, the zillion example, we were trying to determine, mathematically optimize what price point is best for this, business to business opportunity. So things like that. But one of the main things that's very interesting here to me, I'm really into where the cognition happens, right? Every single one of these, cognition's happening. And what I mean by, I'm just talking about thinking, right? So whether thinking is happening in a human or thinking is happening in a machine, that's what's happening. So on the bottom left, when we do descriptive analytics, and again, a dashboard, which I'll share an example of that in just a minute. It's basically a visual display. Most everybody has seen one, a visual display of information, and then you're trying to look at even a graph on what's happening. Most of that is actually being done in your head, right? So it doesn't require much computing power to come up with that graphic. But it requires a lot of human power to take that graphic. What's even worse is the table of numbers, right? Because there's a whole lot of human processing that it takes to try to figure out just a set of numbers. But you take it the next level up into descriptive analytics, the summary analytics, but it's still a lot of it's happening in your head. And then as we move up the chain, we are relying more and more and more and more on computing power to assist us in that process. And then on the bottom underneath there, you can see, we're looking at from what happened, hindsight, to insight, what's happening, into foresight, what's going to happen next. And then the last thing that I want to leave with you with on this graph right here, or this slide, is in the reddish boxes, those to be certain of why it happened, how can we make it happen, or what is the best action, those require causation. And I can tell you right now, the thing that's most misunderstood today is the difference between causation and non-causation. All right, so I'm a big fan of The Office. All right, so there's an episode of The Office, and Michael Scott, he's really underwater, and he goes to Oscar, and Oscar's helping him out with the situation, and Oscar tells him that he feels like Michael should declare bankruptcy. And Michael's all distraught, and he's walking around. But later he comes out into the bullpen of the office, and he climbs up on the desk and he shouts, "I declare bankruptcy." I see this a lot with predictive versus prescriptive modeling. I see people that take a predictive model, and then they say, which is good at foretelling what's going to happen next, and then try to pull levers and assume that what they think is going to happen is going to happen. That's probably the most misused piece of analytics today. And that's kind of one of my things that I'm trying to preach, is you can't simply do this. And let's look quickly at a few reasons why you can't do this. So to effectively do it, you need at minimum these three things, right? You need to be able to establish causation, that they are causative, not correlative in fashion. And you have to be able to manipulate the important variables, right? So it doesn't do you any good to know that, say, gender is important for a model, but then not be able to manipulate the variables. And then the last thing is, you have to be careful, even if everything is right within your system, if you move a lever too hard, you're probably going to perturb the whole system. So the system that existed when you built your model is no longer applicable. And so I'll just leave it at that, but you just have to be very careful when you're going through these things. And we'll just move on for time. So let me kind of back up. I've been using this term model. What is a model in the first place? Well, this is a model. 7. 7's a model. All numbers are models. Humans constructed the idea of counting a long, long time ago. So 7, it's also a whole number. It's an integer. It's discrete. It's halfway between 6 and 8. It's odd, and it's prime, and it pays in Vegas. When I tell people that this is a model, people say, or let me back up. When I tell people they've never actually seen a model or seen a number, they really have a hard time with that. And it's because this is a representation of a mental construct. So models are everywhere. We use them all the time. We don't think of them in terms of models. They're just part of what goes on. But certainly in analytics, there are all kinds of models that take place. So data is about process, and so when it's basically an artifact of a process, and that's the reason we like data. It's not because we like data for itself, but we use data to try to improve processes or understand processes. And so they're all around us, and they drive data. And so that's at the core of what we're really trying to get about with any data collection or any analytics. Let me move on and talk about a particular type of process here. And this was, I'm going to share an anecdote. So the reason statistics is well, it's just difficult. Let me put it that way. So it's hard for most people. And in fact, I have to make a confession. And let me tell you a personal story. So when I was at at Baylor. I was actually teaching in the business school, and I was working on my PhD. And so I knew all the mechanics about statistics. So I knew how to set up hypotheses, calculate test statistics, do critical regions, p-values, et cetera. I knew all the math. I knew all the mechanisms involved in statistics. I saw an article in the American Statistician that basically said, was Ty Cobbs ever a 400 hitter? And I thought, well, I don't understand the question. I mean, I looked at the internet, and sure enough, he had hit 400 3 different times. What I didn't get was what the question really meant. And so, but that wasn't really the intent of the paper, was not whether he ever hit a 400 in any season. That's the reason questions are so important. And there's an anecdote that says that Einstein was given, he was questioned. He said, if you were given an hour to solve a problem, can you say what your problem solving approach would be? And he replied that he would spend the first 50 minutes really understanding the question, and the last 10 minutes trying to solve it. And obviously I blew it when I saw this, because I really wasn't trying to understand what the question was. The question was, if you think of Ty Cobbs as a producer of a process, did he ever really have a 400 average, population average? So in other words, if you think about a machine that produces a widget, maybe it will produce a widget of some large size, and maybe that's a 400. But the process itself is the average is not there. So that's what was being asked, is whether in the process, it was a process question. It wasn't a statistic question. And that was the heart of it. I want to spend a few minutes on talking about some basic groupings or methodologies in analytics. So visual BI, business intelligence, and descriptive analytics, they were created to solve the problem of a single version of the truth. And the data warehouse had the organization's data in it, and the BI sat on top of it. So you had these reports that were single version of the truth. That's really the strength of it, is to get everyone on the same page, rather than everyone bringing into the boardroom their own report and then people arguing about what the real truth was. The data warehouse and business intelligence provided that common base, and it still does. You have, operational BI, the reports that are being produced on weekly or monthly or daily or hourly schedules. And then you have the project-based BI that support different analytics projects. And then you have business activity monitoring and messaging. So this is an example of what I was referring to as a dashboard. People love these dashboards. They're the rage all these days. They're embedded in smartphone apps, web pages, and all over the organization. And I find them addictive because they're so much fun to create and change. You can just spend hours on these dashboards, and they have brush linking, which means if you make a change in one element in the dashboard, it cascades through, and you can see all the changes that occur downstream. And then you have all these maps, right? So maps in layers. If I zoom down in, I can even create maps of buildings and floors and everything else. So you can have a whole layering of these maps, and even streaming, right? So you can have real-time data that's coming through these dashboards as well. So those are some of the strengths of dashboards, right? Humans, through years and years and years of thousands of years of evolution and everything, see these visual relationships, and they get it real quickly. They can pick up on on these relationships. So that's one strength. Humans love to play with things and interact. That's the reason I think they're so addictive, is because, I love to build them out, and there's some creative aspects there. They also, there's very little training, because it's kind of built in our DNA, at least to start. And so a lot of careers start in BI, and then evolve from there. And again, it may offer a single version of the truth if you have these organizational dashboards. And then some of the weaknesses of BI, we have really strong imaginations. And so we see things in these graphics that do not really exist. So you see a relationship, but is that relationship significant? Just because it's in a dashboard, it's a statistic. That means it was collected on the past data. You cannot tell whether that's real or an anomaly, whether it's happenstance or even through a lurking relationship that's behind the scenes that you don't currently see. They're also retrospective, so at least really, and then of course in the mind of the consumer, you can project it into the future. That doesn't necessarily mean that what you're seeing from the past will project into the future. So that's another weakness. And then computers offer more objectivity there, and actually are a lot cheaper for certain tasks and higher ROI. So let's move into the next one, data mining, machine learning. So where do they shine versus BI? So it lets the computer do most of the processing and the cognition, back to that slide with the different type of analytics. The results are mathematically verified, so it's not something that you're imagining. These are at least verified mathematically that there is or is not a relationship between certain things. And then the size of the problem that can be tackled goes up immensely with computer power. Some of the limitations are, you need more education. And where's the fun in this, right? So those dashboards, again, are fun to make. The total cost is higher, but these don't have to be exclusive, right? Better together. You can put the methods together. You can have a BI developer and a data scientist work together, and it often provides a better result. Quickly, a couple things about artificial intelligence. I'm moving a little faster now. I want to make sure that I leave a little time for questions. I just have a few more slides. So these are extremely powerful for pattern recognition, nonlinear relationships. You can literally process thousands of variables. You can't do that in BI, right? You can only process dozens. And then unstructured data, both video, audio, text, and everything, and they really do well. Some of the shortcomings, you can't do AI with just a few rows of data. You actually need thousands of training variables, and they're not very transparent. You can't really read them and how they're doing there. And then you can't look at correlation either. I'm sorry, you can't look at causation. You can only look at correlation. So data scientist, big term these days. I teach at CUNY. We used to be data analytics. They changed the name to master's degree in data science. I have affiliations with SMU and Northwestern. They've done the same thing. They changed from data analytics to data science. So it is the most nouveau term that's out there. I'm going to skip to big data. And then statistics is certainly very, very important for establishing causation. It's really the only thing that you can use to establish causation. And it's used in every single one of the methods that we're talking about. Most people don't even get that. The fact that anytime you take a sample, you're using statistics. And so BI, AI, machine learning, these big data methods, every one of them, you're actually using this paradigm of taking a subset of a population, and that's a sample, and then you're computing a characteristic of that sample, that is a statistic, and then you're making a guess about that population parameter. That's really what you want to know. You want to be able to figure out what's going to happen tomorrow. And so you're using a statistic to guess at what's going to happen to tomorrow. So you're using stats in any data-driven technique, pretty much. And there's certain problems that will never be solved with AI or ML. And then that's a few examples here. Time series and controlled trials. I mean, the FDA, they're not testing drugs with machine learning. They're using statistics to do that. And then the little blue boxes is what I just went through. We have a population that produces parameters. We actually take a sample, produce a statistic, and then we guess back what that parameter is. So I pretty much already covered that. Some of the limitations of statistics, it's a steeper learning curve, and some are just really darn hard. And also, people discount statistics, but it's the blind man and the elephant problem, because they have only really had exposure to one type or another, and not broadly across. And they can lead to the wrong interpretation and isolation. With that, sometimes they're better together. This is an example of just in 10 seconds. These are 4 charts. This actually produced the exact same statistics, but without the graphics, you might go the wrong direction, right? These again, it's better together. With the picture and the statistics working together, you can get a better result. So in the end, there is no free lunch. You need a combination of skills and methods. I teach master's degree students. They come in with these great, neat algorithms, and they think this is the best way to solve every problem. No, the free lunch theorem basically said there's no universally optimal way to approach a problem. That it's totally data and process dependent on which way to go. And so technology is important, but asking the right questions is vitally important, probably more important. And then we can certainly treat this as a team sport. So I want to thank you very much, and we'll go into questions. Just before we do that, everything on the right is a way you can contact me through LinkedIn, Twitter. I'm not that active right now. I'm creating a whole YouTube channel, or I have a YouTube channel, which might be a little bit messy. I cover some technical issues there that you may not be interested in, but I have a playlist called It's All Analytics, and that playlist is going to be dedicated to things that we just discussed and a lot more. So, okay.
Great, Scott. That was really interesting. Lots of great talented stuff going on there. That was super. A couple questions we're going to have right now. Great. Yeah, there's a couple from the audience and then one I just added, but I'm going to do the audience questions first. So, Scott, how do you know the data that is being purchased or received is clean, legal, targeted to my audience, and be of value? Is there anything specific I can look for or ask for?
So, I mean, certainly there's a few things that you can do. I, again, always come back to questions. What questions are you trying to answer? Because you can't really determine the quality of the data unless you know what questions you want to answer with that data, right? So, questions first. And then there are a lot of different standard ways to approach data quality, data cleansing. Some are statistical in nature, some are visual in nature. So there's that. And then there's a whole host of tools available to organizations to vet that information prior through master data management, reference data management, quality, actually even automated quality control checks. Hopefully that's helpful.
Great, thank you. And also, what is your particular stance on using a complete platform as a service offering, like Microsoft Azure, where you can host the database as a managed service and you can use their storage to perform injection or transforms, and their BI tools to write and share reports?
Sure. So I think Azure is the example of Azure is a great platform. I tend to favor, well, of course, Azure is both the data platform as well as Azure ML is the machine learning platform that sits on top of that. One of the things you can go a couple of different ways. One thing I want to make sure that I say is you want to make sure that your platform supports open source methodologies. In other words, it's extensible to things like R, Python, Scala. These open source machine learning and analytics platforms change. And one of the problems with going with some platforms is that they're locked into their own view of the world. And so you can't easily extend them into what technology's coming down the pike tomorrow. Overall, cloud platforms, both AWS, Amazon, Azure, I'm familiar more with those two. They offer some good products and good services. I work for a commercial company, so I'm a little bit jaded. I work for TIBCO. We have our own data science platform. We do support Azure and AWS as data platforms for our data science, and we actually interact with Azure ML and some others. So I guess that's kind of long-winded and rambling, but the biggest thing is to make sure your platform is extensible, which Azure is. So
great.
Make sure that you can use. Yeah.
I'm sorry, I didn't mean to cut you off, Scott. Go ahead.
No, I was just repeating myself. Just make sure that your platform is open to other technologies that you can incorporate beyond the platform itself.
Great. And then the last couple minutes here, I guess this is just a general question, but what advice would you give to state agencies to mature their analytics efforts and program? So I think a lot of it is, if you look at the 4 categories for analytics, there's more probably down towards the bottom with descriptive analytics, and how do we mature up that continuum?
Absolutely. So, the main reason you want to move up that continuum is twofold. Number one, you don't want to just limit yourself to the descriptive, because the descriptive piece can get you in trouble. I've seen it many times where or let me just put it this way. Let's suppose that I am a creator of these visual dashboards, and I'm going to go before the board and I want funding for my particular project. I guarantee you, I can put a set of dashboards together that supports my story, no problem. If I have data and I have imagination, I can pick the columns out that I want that supports my story. I can pick out the types of visualization that supports my story. I can remove outliers that do not support my story, and with good reason, right? They're outliers. So you don't want to end up there. You do want to progress up. So the nice thing about machine learning is that it doesn't require as much education. Everybody should have a base level of statistical knowledge, because statistics is all about probability. The idea of rare events. The whole output of machine learning is probabilities. So you need that, at least a base foundation there. But to move, if you were to go through the statistical branch straight all the way through, it would take you longer. So what I would say is get that basic statistics foundation, right? Know the basics there, then move into the machine learning. That's going to provide you some pretty quick results, because machine learning is fairly intuitive. And the machines help a lot. There's some great products and things out there as well. So, I mean, even as a statistician, I was first schooled as a statistician, then I was schooled as a machine learner. I would say that form the base in statistics, then jump into the machine learning. That's going to give you an advanced start. But don't discount the other statistical methods either, because some of them are very powerful. And some data is small, and you're just not going to do certain things with machine learning that you could do with statistics. So better together.
Great, thank you. Great advice. Well, I think we're coming to the top of our hour. I'm going to turn it back over to Joy to close it on up. Scott, thank you very much for your time. I really appreciate it.
Thank
Great
you, Ed.
Scott, yes, thank you. We were hoping to have you at this year's data forum, which kind of got torpedoed with COVID, but this is even better. It coincided with the release of your book. We're excited about it. Everybody will get a follow-up email. Please fill out the eval as you leave. I think, Scott, you wanted to mention you actually have a coupon for the book too, in case someone wants to purchase, or we're going to include that in the follow-up.
I do, and I'm showing, but you can get it on Amazon as well. So I know that Amazon, I think the price was lower, so you can shop where you want, and I'll include that for you. You can send that in the email, the discount from the publisher.
Okay, so let's go ahead and wrap up. Everybody have a great day. Thank you all for joining us. Take care. Bye.
Thank you.